So here's another question. Function fx is given, its domain is given. Function gx is given, and its domain is given. Okay. Find and simplify an expression of fg. So in f, we have to substitute g, which is 4 upon 5x plus 2. So it becomes 4 upon 5x plus 2 minus 2. Now, when you simplify this, this goes in the numerator and this gets cancelled. So we're only left with 5x plus 2 minus 2, which just gives us 5x. Okay, so that is what fg is equals to 5x. Okay, now next part is state the range of fg. Let's write down fg in front of us. So fg is 5x and we need its range. So first you need to check that do you have the domain of fg, because domain is what helps us find the range. What do we know about the domain of fg? That the domain of fg lies within the domain of g. So do we have the domain of g in the question? We do. The domain of g is x is greater than equals to 0. So the domain of fg will also lie within these limitations. X is greater than equals to 0. Now, if for the function fg, x is greater than equals to 0, then the range will also be greater than equals to 0. So fg is greater than or equals to 0 is the range of fg. Okay. Next part is find an expression for G inverse of X and state the domain of G inverse of X. Okay, let's do that. So first we find G inverse. For that, I'm going to write Y equals 4 upon 5x plus 2. Swap the places of 5x plus 2 and Y. Make X the subject, so 2 comes over here first, and then 5 divides. So I'm going to divide 5 separately. So we get 4 upon 5y, sorry, 4 upon 5y minus 2 upon 5. I've separately divided 5 with both the fractions. There was 2 upon 1 and 4 upon y. So this also works. Okay, so this is going to be the inverse of g. So 4 upon 5y minus 2 upon 5. And I forgot to write y in terms of x. So it's going to be x here, not y. And you may also take LCM and write g inverse of x as 5x is the LCM, so 4 minus 2x. Both of these are correct. This is also acceptable and this is also acceptable. Okay. Next part is find an expression of g inverse of x, done, and state the domain of G inverse. So domain of G inverse is equals to range of G. Now, what is the range of G? Let's go back to the function Gx, which is here. We need the range of Gx. Excuse me. Okay. Here is Gx. Give me a second, please. Okay. So Gx is 4 upon 5x plus 2, and x is greater than and equals to 0. Now, when x is going to be 0, the range is going to be 2, right? When you substitute 0 over here, you get a 2. Okay. And then as you keep increasing the value of x, like it becomes 30, then 50, then 70, 80, and 5,000 maybe, then notice that this fraction starts to get smaller and smaller and smaller and smaller because the denominator keeps getting bigger and bigger and bigger and bigger. So 4 divided a very big number is almost equals to 0, but not equals to 0. It will be very close to 0. It will be like 0.000000000, but in the end, you will eventually have some value. So it's the range of gx is going to be, it starts from 0, but it's never equals to 0, and gx, and the maximum value it's going to take is 2. All right, let me repeat that. Uh, we know the domain of gx. It's x is greater than and equals to 0. So when you substitute 0 in gx, you get a 2. So you will get a 2 at some point for gx. And then now notice what happens to gx as you start increasing the value of x. As x increases, gx starts to decrease, but no matter how big is the denominator, the function gx or the value of gx will never be equals to 0. It will keep getting very close to 0, but it will have some decimal points at some places. So we write gx is greater than 0 and less than equals to 2. Now, this is what we'll write here, but in terms of x. So domain of G is going to be, now we write it as X. X is greater than 0, less than or equals to 2, which is the answer.